speaker who will be also speaking English. So he's already with us, and I want to say hello to everybody and to thank you for coming here. We'll be joining today Mohamed Said. This event is a joint event by PHPSerbia and CODEstantine. So PHPSerbia, as you already may know, it's association of developers. We're now currently, I would just want to use this to say that we are currently searching for new members to help us, with everything. We are organizing conferences and meetups for many years for now, and we have one team especially for Laravel called Laravel Serbia. Had many meetups before, so glad to have Mohamed here today with us. Okay, Nicola.
Yeah, I'm here in front of CODEstantine. It's basically an NGO based in Niš. We organize a ton of tech and entrepreneurship events. We have the biggest flagship developers conference called CODEstantine, which happens once a year in Niš. It's not PHP only, so it's technology agnostic. And we organize a lot of local meetups, both on tech topics and entrepreneurships. We have also over 50 events that already happened, tech events that already happened, mostly in Niš. But now this year we'll be organizing a huge conference in Belgrade as well, end of February. So we're starting to heat up stuff, and we expect about 300 developers and more on the conference and end of February. So this is one of the first activities that we partnered up with PHPSerbia. We have already covered some of the PHP topics back in Niš, but we're super thrilled to now host this co-event, and this event is happening in two places physically, here in Belgrade, where Mladen and I are currently located, and in Niš, No Limit Hub, the home of CODEstantine. So this is an experimental thing also to see how would it work to have the event on multiple places, and depending on how this go, we might introduce some other places and have distributed events so that the great speakers that we bring are available to all the people, no matter the location that they're from. So yeah, that's basically on CODEstantine. So get ready and spread the word about the CODEstantine Belgrade end of February. We have a lot of interesting speakers get prepared in the lineup, so keep an eye on that. You might wanna introduce Mohamed.
First, should we
have
a few words about sponsors?
Yeah, sure.
Yeah. A few words about sponsors who make this happen. So first one is DevTech. I'll send just a few words about them.
Just a sec. Let me screen share.
Yep.
Slides. So, Braco, can you share the presentation?
So I'll just say a few words about DevTech because no one from DevTech was able to attend today. So DevTech provides digital innovation services that help emerging and Fortune 1,000 businesses transform, scale, and disrupt. We combine deep cloud domain knowledge with expertise in software product engineering, user experience, and creative design to deliver end-to-end next-generation solutions that drive desired business outcomes. Our goal is to empower every customer to be the disruptor, not the disrupted. So that's for the DevTech.
Cool. So thanks to DevTech and the crew there for helping us organize the event. Here's the QR code to their open positions. If anybody is interested, take a scan, or we'll distribute the presentation later on. Most probably on the recording. The second sponsor is the company that I run, full disclosure. So it's Product Hive. We create startups that kick ass. We started as a digital product development agency, but over the last 3 years, we've mostly been focused on building our own products. So we have offices in Belgrade and Niš. and a few people that work remotely. We do a little bit of product development, but like we try to build startups end to end. So understand the requirements, the business, the user, all the sides of building a business. We have different teams. This is like one of the offices in Niš. A few photos from this is a meeting room, and some of the people that work with us. These are the two products that we spend most of our time on. One is Amito. If some of you were on the last meetup, I gave a detailed talk about some of the biggest challenges we were facing, how we overcame them. Amito is the no-code business messaging platform. Basically, allows you to send bulk campaigns over SMS, Viber, and other direct messaging channels with just a few clicks. Similar like MailChimp, just for direct messaging channels, all in an easy-to-use unified interface. And the second one is MotionOps, which is, I don't know why this image is blurry, but maybe because it's still in stealth and about to launch in just a month, something we've been working over the last year and a half. And we have big hopes for this. It basically helps fleets, companies that have fleets of handyman and like service people organize their business end to end. So everything from scheduling to work order management, to CRM management, to invoices, to paperwork, to contract signing, everything that done through web and mobile app. And this is our tech stack, React and TypeScript on front end, Laravel and AWS for most of the stuff on the back end. We use a lot of kind of new age technology. We use Vapor, we use Octane, we use Shift. We run everything on PHP 8.1 and Laravel 9. So a lot of the interesting things happening there. We're currently looking for 2 people to join our team. If you have a recommendation for someone who might fit at this point, feel free to reach out or go to careers. And that's about it. These are some social links if you're interested to learn more. And thank you, Product Hype, for helping us make this event happen. That's about it for the sponsors. So thanks to both companies that made these 2 events possible in Belgrade and Niš. And now finally for the big event of today is Mohamed. So do you want to introduce him? And yeah. Mohamed, thank you for waiting and for all your patience to go through the official introduction.
Yeah. So
yeah, thank you for having me.
Okay, so first time I heard about you was on the Laravel podcasts, and you were the first Laravel official employee, right?
Yes, that's right.
Yeah, I think everybody here pretty much knows that. Yeah. Okay, you did a lot of work there, a lot of open source work. So thank you, first of all. Yeah.
Yeah, glad to have done that.
Okay, so I wouldn't spare any more time. So please, you can do a quick intro. Right.
Yeah, so as you all know, the topic of today will be Laravel Queues, and we'll try to dig into some specific use cases and problems that and questions that people might have. So the whole structure is we'll have like a quick, really quick, like 10-minute introduction that Mohamed will give on queues in Laravel especially, and then we have a few questions that we have prepared that we'd like to get the discussion started. And of course, we welcome all of you to prepare your questions and ask them to Mohamed at the second part of the discussion. So Mohamed, the floor is yours. We all want to hear about queues, as it's the integral part of every scalable and kind of basically every application. I don't know if there's a web app which runs without queues. If there is, then run away from that. So we all need it in one form or the other, regardless of the technology we use. So hopefully we'll learn a lot of nitty-gritty stuff and maybe some of the under the hood stuff, as you have been working specifically on queues for a couple of years and have written a whole book about it, and you can feel free to kind of share and invite people to where they can learn about the book as well at the end, if you wish.
Right. Thank you for having me. We've been like trying to make this event happen for the past, I would say, like 3 or 4 weeks, and I'm glad it is finally happening. Uh, as you shared, like this is like a fireside chat. It's not a presentation. I don't have any slides prepared or anything. I'm just here to talk about queues and hear from everyone if you have any questions regarding queues, if you want to know about how we use or how we used queues internally in products like Vapor and Forge and in Voyeur, because interestingly, this is where everything in Laravel started. It's Taylor trying to build something, and he finds that he needs a component or a tool to help him build or maintain or operate some kind of application. So he creates the tool and open sources it in the framework. And that's why you find a lot of great stuff inside Laravel, because it is built with like specific real life production problems that Taylor was trying to solve. So we get together, we think, and we come up with solution to this. So queues is one of those components that were built because Taylor needed something in one of the applications that he was building. So I'm here to answer your questions, but before we start the questions, I will just give you like a brief introduction around queues for those of you guys and gals who haven't used queues before. So as web developers, like you can summarize that a web application is just a series of procedures that pass data around. Like it reads the data from a request, incoming request from a user, and it passes it around through several layers, generates a response, and then sends this response data back to the customer. So you can say like a web application is a form of a data pipeline: data in, some processing, and data out. It's like an industrial pipeline. And like an industrial pipeline, the data or the stuff needs to pass through one pipe to another until it reaches the end. So a request comes in, some middlewares run, then the controller actions run, some validation, maybe speaking with the database, reading and writing data, some caching layer here and there, and then the response is generated and sent back. This is a pipeline, several pipes connected together, and the data passes through them. And a single web application instance can only handle one request at a time. So in order for you to speed things up for an application, you need to like shorten or decrease the number of pipes the data will pass through. So let's say if you drop communication with the database, things will be faster because we no longer need to communicate with the database. That's one pipe out, so the pipeline is shorter. That's what speed things up. And having like connected pipes, it means also that slow operations not only delay the response of one request, but also delay handling other requests. So as we said, like a single pipeline handles a single request at any given time. So if you want concurrency, if you want concurrent users to be able to communicate with your web application, you need to install several pipelines. Let's say you have 40 pipelines. That means you can serve 40 requests concurrently from different users. So with a slow pipeline, that means if you have more than 40 concurrent users trying to communicate with your applications, some of your users will have to wait until the available concurrency slots or the available pipelines or the available processes complete what they are doing so they can handle more requests. So slow operations just makes your application less scalable. In order for you to be able to serve more customers, you need to do like a few things. You can buy more machines and run more pipelines. So instead of 40, you can run 80, so you can serve 80 concurrent customers or users. That's one option. Another option is for you to buy more computing resources. So instead of having more machines, you invest in the current machine, have a bigger one, and make it handle 80 processes instead of 40. And these two options, of course, are expensive. And the third option is to do things faster, is to optimize your code, maybe to make it run faster. That way, the 40 concurrent users will be served faster, so you can take extra users from the internet. So optimization is one form of doing it. The other form is concurrency. So instead of a single pipeline having one step after the other, you can use concurrency to have like a single pipeline that receives a request, but then instead of passing things one after the other, it will branch out to several pipes, running things together, doing things at the same time. And that's way, instead of having like a very long pipeline, you would have a shorter one that does the same thing, but you are utilizing several concurrent operations happening at the same time at the same request. But if you are familiar with PHP, and of course many of you are, there is no actual concurrency in PHP. There is no threading in PHP, and there is no built-in coroutines. Like, of course, you can have coroutines using something like Swool. Swool is a PHP extension for those of you who don't know it, but that's extra work for you to install an extension, set things up so that they can work concurrently. And if you're using Laravel, unfortunately, Laravel doesn't work with the coroutines model due to several reasons. I don't think this is the place to discuss this, but it doesn't work. So concurrency is not actually an option available to PHP developers out of the box. You need to do extra work, and you need to bear in mind a lot of things that you wouldn't normally have to think about building like a regular application in the regular model of PHP. So with optimization as an option, concurrency as another option, the third option would be asynchronous task execution. And that's basically what Queues does. So with asynchronous task execution, you're not running things in parallel. You're just going to look at your pipeline and pick the pipes that doesn't have to complete, or you do not need to pass the data through these pipes while processing the request. Say, for example, sending an email. Your user signs up and you need to send them a welcome email. So you can take the pipe that sends the email and do it later. So that way your pipe will include getting the user information, storing it in the database, responding to the user immediately, and then the welcome email will be sent later. And by doing so, you decrease the size of or the number of the pipes in the pipeline, and thus you have a faster pipeline. So again, out of all these options, two options are expensive: buying more machines or investing in the current machine to have a larger one. And one of the options, which is optimization, it is obvious that you need to do optimization in all cases, even when using queues. But if you have done everything you can possibly do to optimize your code and optimize your system, and that's it, there is no more optimization that you can do, then the option that you have to make things faster is to perform things asynchronously in the background. So that's basically where queues come in. So another definition, or another way I like to look at queues with, is like, we know like a user interface, like we all deal with websites and we build websites actually. So a user interface is how humans interact with a program. And an API is how programs interact with each other. So a programmable user interface, that's the short for an API. So you can think of queues as like, it offers a programmable interface that program use to communicate asynchronously. So instead of like calling the Forge API to create a server, using queues, you can delegate one of the processes that you control to call the Forge API to create a server sometime later in the future. And then you can hear back from this process what happened. Did the server successfully got created? Did anything wrong happen along the way? So all this time of waiting, you don't have to do it, or your program doesn't need to wait. It can do other things while this operation is done in the background. So a queue system is an API, but instead of performing things like on the spot, it delays them and it performs them sometime in the future. So it basically allows you to offload tasks to be handled later. And by later, it could be in a few milliseconds, it could be in a few hours, all based on like the size of the queue system that you have. If you have a lot of workers waiting for jobs, that means that jobs will be processed faster. If you have like only a limited number of workers, that means the jobs will take some time until all of them are processed. So you control the rate of asynchronous task execution, the rate of processing, by investing in like having more or less workers. It all depends on you and how, like, and the priority of the kind of jobs that you are dispatching to the queue. So this is like a brief introduction to queues. Like, I didn't want to get into anything technical and didn't want to have like a deep look into how the queue system works, what workers are, how the jobs are getting dispatched. Because again, like, I'm here to hear what you guys need to know, like if you have any questions, this kind of thing. So this is my introduction, and if you have anything that you want to share, I would be happy to answer.
Thanks a lot for the brief introduction. Definitely just scratches the surface on a lot of topics. Each of the three types is a topic for itself and would be interesting to talk more. But let's stick to queues and dig a little bit deeper there. So can you explain the different types of queues that exist? And in general, because you can have a different underlying architecture, so what do you use as a queuing system or an infrastructure? Can you elaborate on, is there any potential differences in terms of implementation, algorithm used to dispatch, or limitations if you're using, for example, AWS's SQS, or if you're doing it through Redis or using Horizon or whatever?
All right, so like the basic idea of how the queue system works is that you define like several queues, and you can think of a queue as a table in a database. This table contains several jobs, and it is sorted by like the oldest jobs are sorted first. So when a worker tries to pick a job up, it's going to find the oldest job in this specific queue, picks it up, processes it, and then moves to the next job. So this is like the basic idea of how queues work. Now, when you are building an application, there are two main types that people talk about: first in, first out queues and regular queues. Laravel built-in queue system is just a regular queue. Like, it is a bit confusing because it operates on the model of also first in, first out. Like, the first job that is dispatched is the first job that's going to be processed. But there is like a more concrete definition of first in, first out queues. And for those of you who are familiar with SQS queues, AWS SQS, they have a dedicated type of queues called first in, first out. Laravel doesn't work with this kind of queue out of the box. It works with a regular queue. So what is the difference between both? To Laravel, first in, first out means that a worker is going to pick the oldest job up, process it, and then move to the next. First in, first out in terms of AWS SQS means that a worker is going to pick the job up, process it. Only if this job was successfully processed, it's going to move to the next job. If this job fails, the worker will keep retrying this job, will not pick any other job, will keep retrying the job until like the number of tries are exhausted, and then the worker will just stop, do nothing until you tell it what to do next, or the job successfully is processed and then it moves to the next job. So this is the main difference, and this is like a very popular point of confusion. People normally say, like you say, that Laravel queues are first in, first out, but jobs are not processed in a first in, first out manner. If jobs are fail or are got released, they will be skipped and the next job will be processed before the first job. So this is like the difference between the two jobs. But in general, the built-in queue system that ships with Laravel framework, it doesn't support this kind of SQS first in, first out model. The first in, first out model in Laravel means that the oldest job in the queue will be processed. If this job fails, if it was released back to the queue, it's going to move to the next job immediately. It will not wait until the first job is processed successfully. So these are the main differences. I hope that answered your question.
Yes, it does, but it opened a few other questions. So can we talk a little bit more about queue prioritization? So we can have, of course, different queues. So like you can choose how the infrastructure you put them on. But as you said, it's first in, first out. So how do you prioritize between more important stuff versus the less important stuff on one end? And on the other end, like if you have two jobs which bring in, let's say, 100,000 smaller individual jobs each one, but the first one came in first, the second one by default will wait for the first 100,000 to get executed. And in some ideal case, probably in most cases, you would want to kind of take a little bit from one side, take a little bit from the other side, and kind of evenly distribute the execution between the two. So can you explain the difference between these priorities and how would we accomplish something like this specific example?
All right. When you talk about job priority, like there are two kind of things that you need to have in mind. First, like by priority, would you mean that the jobs in this queue are more like I am more interested in processing these jobs first before any other jobs, even if these jobs aren't the oldest one. So let's say you have a kind of job that processes payments and another kind of jobs that sends emails. Let's say you have like 1,000 jobs that sends emails in the queue and then a payment job came to the queue. Do you want that payment processing job to wait for the other 100,000 jobs before it gets processed? Of course not. You need to have like any payment processing job to be processed first, and then you continue with the normal first in, first out mode of processing queues. So this is one way to look at prioritization. Another way to look at it is you would want to say that even if I have like a great number of jobs that process payments and then equally big number of jobs that sends emails, I want to allocate more workers to the job processing or the payment processing jobs so they get processed faster. So these are the two ways you would look at prioritization. How many concurrent jobs of a certain type that you want to process, and that way you speed up the processing of one type of jobs, and should the order of dispatching be respected or not when it comes to a specific kind of job. So again, back to the payment processing job, if I am working on a product or a project that has a payment processing job, I would isolate this kind of job that does payment processing in a specific queue and allocate more workers to that queue, and then also configure that queue to have a higher priority than the other queues. And by that, I mean, if there is any job in the priority queue, the payment processing queue, process it before you look at all the other queues. So only if the payment queue is empty, you will start process other jobs. And also, if the payment queue is full and there are other jobs as well, allocate more workers to the payment queue, so jobs there gets processed faster, and allocate a few workers dedicated to the other queue. So if the priority queue or the payment queue is completely full, you do not, or your workers do not just focus on it. You will have some workers dedicated to the other queues as well. Now, the second question, when it comes to dispatching like large batches of jobs, this is always an interesting problem because approaching it like requires more details, more of the nitty gritty of each what these jobs do. So, for example, if we have a batch of jobs a batch that sends 100,000 jobs of sending emails and another batch that sends 100,000 jobs of processing payments. Second, of course, you would want the second batch to be processed first. You would give it more priority. And that's how you do it, by separating these in different queues, and you give the payment queue higher priority. So even though 1,000 jobs were dispatched first to send emails, the workers will focus on the secondly dispatch or the later dispatched batch of 100,000 jobs of processing emails. So that's how I would think about it. But if both the jobs are of the same kind, like for example, 1,000 jobs for sending emails and another 1,000 jobs of sending emails, there is no way you can tell the queue to isolate the second batch of jobs and process these in parallel, because for the queue, it will process things older first in, first out. So again, if all the jobs are all the same kind, you do not really have like any kind of prioritization model, then just you have to let it do its thing. Process jobs as first in, first out. But if some jobs have more priority than others, then you separate them into a different queue and give this queue more workers, more allocated workers, and more prioritization. Hope that answers your question.
Yeah. Thanks for the detail.
A few more.
Yeah. You want to jump in?
Okay, so having in mind that you work with Taylor very closely day to day, on Laravel stuff in general. Can you tell us how much of the Laravel framework gets booted when a new job is started? Is there some like tactics or stuff or some improvements in plan for the future?
All right, so like you process jobs by starting several workers. So each worker bootstraps the Laravel framework from scratch and keeps this instance in memory. So the framework is bootstrapped once when you start the worker, and it is kept in memory. And this instance of the framework that we call a worker, what it does is that it keeps checking the queue and make sure that, and check if there are any jobs in that queue. If there is a job found, it will pick it up and starts processing it. So for each job, the framework is not dispatched or is not bootstrapped from scratch. It's only bootstrapped once in a lifetime of a worker. And this same instance is used to process all the other jobs or all the jobs that come in. So to answer your question, for each job that gets processed, the framework is just there. It is ready to handle requests. It doesn't get bootstrapped from scratch.
Thanks. Okay, and
so just to dive in on that one. So basically, if we add Octane to that, it means that it's already booted in, so there's no need for that, but the Octane would add the parallelization of the threads if there are multiple processors. Is that correct?
Yeah. Octane converts like the regular web requests handling to work the same way as queues. So in a regular PHP FPM setup, you would start PHP FPM, and PHP FPM will start several processes, one process for each request. So for each request, the framework gets bootstrapped from scratch, handle the request, sends the response, and then the process gets killed. Another request comes in, framework from scratch, handles, gets killed. That's how the PHP FPM model works. The worker model, which is provided by Octane, it doesn't do that. it bootstraps the application once when you start Octane, and then the same instance of the application handles all the incoming requests. The framework doesn't get bootstrapped on every single request like it does with PHP FPM.
Oh, okay, one easy one. So can you tell us some fun stuff in terms of implementation of queues that we might not be aware of?
Yeah, like there is one like a very interesting use case that I've seen, and I've actually you can find more details about that in my book. It's one of the chapters. Of course, I can't remember which chapter exactly, but it's there. Like, it is a case of implementing first in, first out queues, true first in, first out queues inside Laravel without having to rely on SQS. So if you're using Redis or if you're using the database queue driver, you can have this as well. And this use case has to do with chatting, messaging. And for messaging, you need to deliver messages in order. You cannot, like, if delivering a message failed, you cannot just deliver the message that comes after it and then change the order of the messages that gets dispatched to the user. You need to have a true first in, first out model there. And the way to do it in Laravel is by using job chains. And chains were not, or they weren't designed to work with this, but from my testing on several applications, it really works well with that. And the way you do it is like this. You start a chain, and this chain keeps dispatching itself. So it keeps itself in the queue all the time. And the chain has a job, and the job checks if there are messages that need to be processed, and it dispatches those messages to the same chain inside the queue. So the chain has a job that keeps filling the chain and then dispatches itself at the end. So that way, or if you're familiar with Laravel chain jobs, if the first job in the chain fails, the second job will not get processed. Laravel will keep retrying the first job and will not move to the second job until it is completely succeeded to process the first job. So this is like a very interesting use case. And when I suggested it to one of the community members, I wasn't sure that it's going to work in production, but then he has been using it for, I think, 2 years, and it's working great. So you have a chain, the chain has a job, the job keeps dispatching the chain over and over and keeps adding job to the chain. So the chain lives in the queue forever, unless you, of course, have a mechanism to tell it to remove itself from the queue. So this is like an interesting use case that the queue system wasn't designed for, but it works.
Okay.
Nice hack, definitely. So while we on it, maybe we can talk a little bit about failed jobs, and let's start with in general, how do you debug stuff in Laravel? Are there specific tools that you use, and specifically, how do you debug queues, and where do you start? What's your process to actually figure out what's wrong?
All right, like there are a few failure points in the queue system. Like sometimes the application would fail to dispatch a job to the queue. Like if the queue system is down, for example, you're using Redis and Redis is down, the application is trying to dispatch a job to Redis. This, of course, will fail. So failure while dispatching a job. And there is failure to fetch jobs from the queue. Again, the worker is alive, but the Redis instance is down. So each time it tries to pick a job up, it just fails. And then there is failure to process jobs. And there is failure to report that a job got successfully processed. And then there is also the failure to say that a job has failed. So there are many like failure points in the queue system. And like many of these fail points are quite easy to debug, because if a job dispatch fails, you will get an exception, and the exception gets logged in your logging system. So you will know that dispatching jobs is failing. If fetching jobs fail, an exception will be thrown. Processing jobs fail, an exception will be thrown. Same for reporting the job failure and reporting job success. So like for these kind of things, the debugging is straightforward. You get alert that an exception was thrown from your application, you go check and you find where it's happening. Redis is down, processing job is failing due to like a database issue or something, or a bug or whatever. So this is all straightforward. The thing that I find most like annoying to debug is when you suddenly get a call from your boss or from customers or whatever, and they tell you that the system is not working, jobs are not being processed, something is going on, and you're not aware, you can't see any exceptions, you can't see anything in the logs, just the queue system is like, it keeps filling up with jobs, workers seem to be up and running, but they are not processing those jobs. So this is like the most like annoying or the most hard to debug thing. Fortunately, this doesn't happen a lot, but when it happens, like once you get like, the first thing I would do when I see this, and we have done this a few times with Forge, Envoyer, and Dutch, you just restart the workers. By restarting the workers, you are killing all the worker processes and starting fresh ones. These fresh ones, they will just start processing jobs as usual. Like most of the time when this happens, it's due to the worker processes are frozen. They are frozen either waiting for something, or frozen because like the operating system is trying to kill them due to like a resource limitation issue, but they are resisting this, and there's back and forth happening between the operating system and the workers. Like there are many reasons for this to happen, but solving it is easy. It's like I remember my father used to say, like, with mechanical problems, knowing the problem is easy, but fixing it is difficult. With electrical problems, knowing the problem is very difficult, but once you know where the problem is, the fix is easy. So like this is the kind of things that, as long as you know there's a problem, the fix is easy. Workers are there, the queue is filling up, but no processing is happening, just restart the workers. So again, like there is nothing special about debugging all the other failure points in the queue. You just receive an exception and you act upon it. But for like frozen queues, just restart the workers, and most of the time this will solve the problem.
So typical, have you tried turning it off and on again? Usually solves the problem.
Yes.
So,
Okay, so regarding failed jobs,
yep.
If a batch fails, is it possible to retry just the failed jobs specifically?
Yes, there is a command that you can use to do that. You can, I can't remember the actual name of the command, but there is a command that you can find in the Laravel docs that allows you to say, like, find this patch by its ID and get all the failed jobs inside this patch and dispatch them back to the queue so they are retried again. So yes, there's a way to do that, definitely.
Cool. And when we talk about scaling, and Vapor comes to mind as kind of the serverless technology, and like something that the Laravel ecosystem is also pushing for. We, for example, have been working a lot with it for the last maybe 2 years. And like working with Q specifically has been a little bit weirder than before, and like feels like you have less control over the stuff that happens there. So can you explain the difference between queues on serverless environment versus the regular environment? What's different there?
All right, like for the serverless environment, when you're running on Laravel Vapor, you only have one option for the queue driver, which is SQS. You cannot use Redis, you cannot use a database. And the reason for that, you do not have workers. You do not have control over a computer, a machine where you can run several processes. These are workers that fetch jobs from the queue. So the only way you can deal with it is to rely on AWS's own Lambda SQS integration. So with this integration, you do not have workers that keep picking jobs from the queue. This integration keeps checking the queue for you. And when it finds jobs in the queue, it will invoke a number of Lambda functions or a number of Lambda containers of a specific function to process those jobs. The only control that you have over when you use Vapor or when you use serverless is how many concurrent jobs that you want to process. So you can say process only 10 concurrent jobs, 20, 30, 50. Like you can control the number of concurrent containers that will be used to process jobs. And of course, the higher the concurrency, the faster your queue will be processed. And the other thing is you can control which queues this specific function, this specific queue function can process jobs from. So you can, and that way, and that's basically how you control which jobs belong to which environment and which project when you have several environments and several projects running on the same AWS account. So these are the two things that you have control over in queues. You do not have a way to do prioritization because the Lambda SQS integration, it treats all queues equally. If you want to implement prioritization, you need to have multiple functions processing jobs from the different queues, not a single function. That way you can control, or you can say, for this function, I want you to process jobs from the priority queue, and then you give this function higher priority. So you give it 10 concurrency slots. The other function, it's a low priority function, so you give it 5 concurrency slots and you make it process jobs from the low priority queue. So that way, if there are any jobs in the high priority queue, they will get processed even if the low priority queue is filled with jobs. With the current model where that Vapor operates, you only have a single function. And if you have a high priority queue and the low priority queue, while the high priority or the low priority queue have a lot of jobs, a ton of jobs, jobs in the high priority queue will have to wait until the Lambda SQS integration processes all the jobs from the filled low priority queue before they move to the high priority queue. So you do not have like a lot of control over prioritization here. You need to be more creative and you need to have more functions and think about how you want to orchestrate these functions to process jobs from the different queues. So I hope that answers your question.
Yeah,
that's pretty much it.
Yeah. Thanks. Yeah, that's definitely kind of the field where we felt the Vapor is lacking the most and kind of this control. So are you saying that basically is there a way to automatically deploy the project with multiple functions that can be used through queues, or that has to be done through manual layers, or however you need to do that to accomplish that?
Well, there is currently no built-in way to do that in Laravel Vapor, but you can get creative. Like, for example, you can have multiple environments for the production environment. So in Vapor, you can have, let's say, you have a staging environment and you have a production 1, production 2, production 3. And you can make the production 1 environment process jobs from the low priority queue, and you give it like 5 concurrency slots. And then the production 2 environment to process jobs from the high priority queue, and then you give it 10 concurrency slots. So by doing so, you can have multiple functions that process jobs from the different queues. So you can do it definitely by using multiple environments inside the same vapor.yaml file.
That's interesting. Definitely, like the view that I haven't considered. The other problem is that, like, even though you can set that, again, the overall stress that it puts on the database is still harder to predict. So you are either under provision or you over provision, and then you risk a failure of kind of overflow, now flowing, but stressing out your database connections.
Well, the way you think about managing database connections is like I would give the HTTP Lambda the highest share in current. So for example, if I know that my databases can handle 200 concurrent requests or 200 concurrent connections, I would give the HTTP function like 100 concurrent slots. So in like the peak of traffic, we will have 100 database connections allocated to the 100 concurrent containers for the HTTP functions. And then I would give, or I would distribute the other 100 connections to queues and to the scheduler, to CLI commands, like the way, like you need to measure, of course, like this distribution is like more productive if you have a way to measure what the needs of your system is. For some systems, HTTP traffic is not that much, but the queue traffic is a lot. For other systems, the queue traffic is not that much, but HTTP traffic is a lot. So you have to think about the type of application and how the application runs. You need to check the numbers, you need to check the logs and know what happens to your application throughout the day, through weekends, through like holidays and this kind of stuff. And that way you can measure how to allocate the database connections to the different functions, and you control that using the reserved concurrency that AWS provides and Vapor supports.
Thank you, Mladen.
Okay, so from your experience, what are some of the most frequent mistakes developers make when it comes to queues?
The most common mistake is that they would think that the queue jobs, that the jobs will operate the same or within the request lifecycle. So for example, a user is logged in and you want to dispatch a job that sends email to this user. So within the handle method of the job, you check who the logged in user is and you send an email to that user within the job. This might work locally when you use the sync queue, because the sync queue runs drops synchronously. So within the request itself, so there is the request context, we know who the logged in user is and such. But then when you move to production, these drops run on a separate process. The request context is not there. So when the drop runs and the code tries to check who the logged in user is, it won't be able to find it because there is no logged in user. There is no request at all. There is no sessions. So this is the most common mistake.
Okay, so from there are so many modules in Laravel. So what's the thing about the queue systems that got you so interested in it? So you tackle that one specifically.
Yeah, to be honest, like I've been working in the web industry since I was 14. Like I got my first freelancing job when I was 14. So I've been handling web requests, HTML, processing jobs, validation for a very, very long time. So with queues, it's a completely different story. You have to think about concurrency. You have to think about when the job should be processed, how to debug different things, how to manage like scalability, how to manage not just scalability in terms of machine, but also scalability in terms of the queues. You have several queues. Some queues get jobs more than others during different times of the day. How you would orchestrate all this to have the most efficient system that you can do. So like this feels like another level, not another level, like it feels like a different thing. I would say that like the title web developer is a bit like broad, is a bit general. Like there are so many details in a web application that requires different people to focus on different things. Like for someone to focus on handling requests and presenting a response, this is like a complete job on its own. For someone to handle how to deal with jobs in the background, that's another job. For someone to think about how to interact with databases, that's a different job. How to interact with the cache, that's a different job. But in the modern day, everyone is a full stack developer. Everyone is supposed to do all these kind of things. But in my opinion, at some point, when a company grows large, you need to have people who are focused on like specific areas of the web application. People who would spend more time on finding ways or the most efficient ways to present HTML, the most efficient ways to deal with the database, the most efficient ways to deal with the queue system, so on and so forth. So after some time in your career, you have to pick something. You have to pick what makes you feel more like problem solver. After some time, your mind grows numb to the problems it has been solving for a long time. So that's what happened with me. I needed to solve different problems, and the queue system gave me that, and that's how I got interested in it.
Awesome. So you learn all the regular stuff during your child labor phase, and then afterwards you decided to go to some hardcore stuff. Cool. So I think it's enough on questions from our side.
Yeah, these are pretty much questions from our team and from some from community. So yeah, now we can.
Yeah, we can have a few more questions.
Somebody maybe have a question.
Feel free to raise your hand. You can say it in Serbian if you're worried about your English. We'll translate, so don't worry about that. Also for the people in niche, feel free. You can also write down the questions in chat. Maybe that will be the easiest, or you can tune in, however you find it easier.
One about Mohamed, you living in Egypt, Hurghada, and many people here coming there, and I've been there, and scuba diving is my obsession. After that, do you do that, and do you have some nice spots for that?
So I don't know if you managed to hear him, Mohamed. Do you want me to repeat?
Yeah, so please repeat.
Yeah, we tried to make the setup with 2 extra mics and 2 extra computers, but it was too complicated for like 4 engineers here to figure out. So what was the mic in, what was the mic out, how to not get the microphone and have 2 people speak on mics while also having the speakers from the back. Mission impossible. Feels like a deadlock. I don't know if anybody knows the solution to this. Feel free to email it to us and we'll distribute that to everyone later. Yeah, so the question was, so you are from Egypt, from Hurghada, and Milan here loves diving.
Yeah,
scuba diving. Yeah. So he's asking if you have some specific spots to recommend that he should visit next time.
Yeah, that is far away from the queue. Like this is like a different question that is not related to queues at all. So yeah, in Hurghada, I think like I'm more interested in free diving than scuba diving, to be honest. But there are several beautiful spots for scuba diving in Hurghada, and the most popular of them is the Giftun Island. This island is very big, and there are different spots for different things. Like if you want to dive with sharks, there is a place there to do that. If you want to dive with dolphins, there is a place to do that. If you just want to go to a relaxed place where you dive to 20 meters and just watch the fishes and such, there is a way to do that. So definitely check the Giftun Island.
Sharks.
And right. If no one has a question about queues, I would just want to ask, like, raise your hands. I can see you. Raise your hand for those of you who have used the queue system before. Just raise your hands. Yeah, so many people have used it. Yeah.
Yeah.
So like my other question is, do you think that, or what areas in the queue system that you think needs more attention from the maintainers of Laravel to make it easier, to make it more performant and such? Because many of you have, I'm sure, like have friends who do not use PHP and use other languages, and they keep saying that PHP is not performant, you do not have concurrency, you cannot do asynchronous, and this kind of bullshit, if you allow me to say it. So if you have some areas that you think need some attention from the Laravel maintainers when it comes to Laravel queues, what comes to your mind, if there is any?
Anybody?
Anybody?
Debugging. We have debugging.
Debugging, yeah.
What do you find lacking in terms of monitoring with Laravel?
Like interface or the functionality.
To be honest, I implemented like a custom queue system because of the request for the client.
Sorry, so to be honest, you implemented a custom queue system as a request of the client. I'll repeat just because he's far away and we don't have an extra mic.
Later, when I switched to Horizon, I found a lot of lagging things that I missed from the custom system. Like I could stop the specific type of queue, I could debug better, I could just monitor everything.
So-
When it was custom, a lot of things were lagging in the Horizon. So my question is there maybe some other tool that's better than Horizon, like commercial?
So a lot of things were said there. So let me try to repeat. So he used the custom queue, and that was really, really good. Then he switched to Horizon, and then he found a lot of things lacking on the Horizon. Not specifically mention what, so that might be useful. And then is there another way except for Horizon that might be slightly better? I'm guessing like if you have Horizon is probably the best you can find. If you compare to anything else out there, it's even worse. But I don't know, Mohamed, anything else?
Like if the question is about monitoring, and that's why you want to use Horizon, but you find it lacking, is that the question about monitoring?
Are there any plans to improve it or expand the Horizon maybe in some ways?
Are there planned improvements or expenditures of Horizon in some ways? Or is the Horizon that what is by now?
Monitoring, right? In a sense of monitoring, right?
Yeah.
Yeah, in a sense of monitoring.
Yeah, I don't think there is like much to be done in Horizon, to be honest, to make it more aware of how jobs run behind the scenes. Like this is something that is like not a feature. It's like if you do things asynchronously in the background, monitoring is crucial. It is very important. But if you monitor everything, you need to be ready to pay for it. So each time you log an event so that you can monitor it, this logging needs to be stored and this storage needs to be maintained. Horizon tries to only like log the important events that we thought as a Laravel team that they are important to people to know about. If we try to monitor everything, it means you have to maintain two systems, the queue system and the monitoring system that monitors the queue. So as a general like library that we put out there for everyone in the Laravel community, we like as any tool, it is a bit opinionated. So we sat together and we thought, what are the metrics that people would be most interested, or not people, like 99% of people would be most interested in knowing about. For the 1% that needs specific metrics, specific kind of logging, it's very difficult as a tool made for the general to cover the needs of everyone. So I would say that Horizon is pretty much done. It covers like many of the use cases or many of the monitoring needs that we have heard of. And it is up to people who want to monitor more stuff to build their own monitoring tools on top of Horizon. and on top of the tools that Laravel offers in general. So you can use Telescope, for example. If you are on AWS, you can use the CloudWatch logs to do like more monitoring or to implement more monitoring. So it is up to every individual team or individual developer to develop their own monitoring experience the way they like it. So there is the opinionated way that we think will work for 90%, if not 99, and there is also room for extension for people who want to monitor more stuff.
If I might add to this, so we have actually implemented a more complex monitoring custom system, and you can do it fairly easily, like literally in less than a day, in CloudWatch dashboards, and you can define which metrics you want to track. So basically on SQS, if you're using SQS or whatever, Lambda or whatever, you can pick each parts of the system you want and select which metric you're tracking. For example, whatever. If it's RDS, max connection limit. If it's SQS, number of jobs, average time in the queue. So like there's like 20 to 30 parameters you can track, and you can create graphs for each of them. And it's basically just like a JSON file that you define, and it determines what gets output there. You just need to use the IDs of particular functions and yeah. We'll talk later with the beer. It will be easier. Yeah.
Am I aware enough that worker processes really have memory limitations? So we need to be aware that we need to terminate each worker once in a while to prevent memory leaks. Is that correct? Or obtain at least?
So the worker, the question is how he understands the workers don't have a memory limit. So is that the fact or a misconception? So does that mean that from time to time, because of potential memory leaks, the workers should be restarted just in case from time to time?
Yes, that's true. And that also works not just for the queue workers. This also works for in Vapor, even for handling HTTP requests. Like each Vapor container handles 250 requests only, and then it gets killed, and then a new container starts. Same with Octane. It's better if you restart the processes like every now and then, so that you free the memory and you start again from scratch. And the reason for that is not because of a memory leak in Laravel. It is mostly because PHP itself is not known for shared memory architecture, where people would expect the PHP process to be killed after handling a request before a new request starts. So packages, libraries, extensions, they were not designed with handling memory in mind. They just dump things in memory, and they don't bother with cleaning the memory after that, because they are not accustomed for that in PHP, because that's not how PHP is advertised to work. It's shared nothing architecture, promotes that you just dump things in memory, don't worry about it. The request will be handled, the process will be killed, a new process will be started with fresh memory. So when using workers, either Octane workers, queue workers, or Vapor that runs serverlessly, it is advised, yes, that you keep restarting the workers every now and then, just to make sure that the process doesn't run out of memory while in the middle of processing a job. So the operating system kills this process in the middle of processing the job and leaving your system inconsistent. So regular restarts helps avoid the issue of memory leaks when it comes to PHP.
Yeah. When it comes to queues that we didn't mention, on AWS, you have like a payload limitation that you can put into queue. I think it's 256 kilobytes or something like that. So
Yeah.
very, very little. So you cannot pass large files and stuff that you used to. So you always have to pass by like a link and then get the queue to actually pull the stuff and do it. So that's different than, that's another limitation.
I would say that not just when using the SQS queues, in general, try to keep your jobs light or self-contained. You try to keep the payload small, because even So like the Redis queue, you can send jobs as big as you want, but you have to be aware that those jobs live in the server memory. So sending too large jobs, you will eat all the available server memory. Same if you use the database queue, for example, you will eat all the storage available. So try to make your jobs like just reference the things that you want to grab, and then you grab them within the job or while processing the job. You do not send that in the payload. Just try to do that in general, not just with SQS.
We have time for maybe one more final question, and then we'll be wrapping up. Anyone wants the final question, or we let Mohamed go? Cool. So thank you very much for taking the time to speak with us today. It was a really interesting discussion, and I think we do have a lot of more questions we would ask on this and on other topics, so I hope this is not the last time we speak. But thank you very much for your time. We would like to thank our sponsors, DevTech and Product Hive, for making it happen, ICT Hub and No Limit Hub and Niche for hosting the event, PHPSerbia and CODEstantine as kind of the main organizers of the event. I encourage you all to go and buy Mohamed's book. Laravel Queues in Depth is the name, if I'm not mistaken. Correct me, Mohamed, maybe.
In action.
Laravel Queues in Action. Yeah, sorry. Our event is in depth. The book is in action. So go check it out. It's not expensive, but it's super valuable. A lot of real world examples from Mohamed's experience are there. And it's definitely worth the buy. So totally recommend it from our side if you want to dig deeper into this topic and see how some of the best companies have solved some of the frequent queuing issues. That's the place to go. There's no better resource for that. Yeah. So to not keep everyone wait, because we have some drinks both in Belgrade and in Niš. I'm sure everyone are eager and already feeling a little bit warm. So need to get cooled down.
No drinks for me. No drinks for me.
That's what I was asking, but it would make me feel rude to ask for your home address. I don't know what you would have thought if I asked you for that on the first.
No, that's fine. That's okay. You guys enjoy. Have a great day.
We owe you one, that's for sure.
Thank you.
So thank you very much, and make sure you follow PHPSerbia and CODEstantine for more awesome events on meetup.com, LinkedIn, Twitter, and all the other stuff. Thank you, guys. Bye, Niš. Thank you for being a part of it. Hi, Belgrade. Yeah. Have a good time, and thank you.
Thank you. Thank you for having me, and have a great time.
Bye.
Bye.